Improper belt tension is one of the most critical aspects when we talk about combating premature belt failure. Undertensioning can cause the belt to slip, leading to premature belt failure, while overtensioning can cause bearing in belt failure. In most cases, technicians use a rule of thumb to estimate proper belt tension, the most common being a 1/2 inch deflection or deflecting the width of the belt. But in both cases, technicians fail to take into account the amount of force required to deflect the belt that distance. Ultimately, tension is a function of two things: its deflection and its force. To measure both of these accurately, you will need to use a tool such as the Browning spring-loaded tension checker and follow the steps outlined in this video. The first step in measuring proper tension is calculating deflection. Deflection is a linear equation in that you deflect the belt 1/64 of an inch for every inch in span. Setting the required deflection on the Browning tension checker can be done by measuring belt span and then setting the bottom O-ring on the tension checker at that point. So in this application, I use a straight edge or a tape measure, and I measure span at 15 inches. So 15 inches is the point at which I will set the bottom O-ring for proper belt deflection. Now that you have the bottom O-ring set at 15 inches, you can set the top O-ring at 0. This is done by sliding the small O-ring down the plunger until it touches the yellow or white stop. Okay, now we're ready to take a tension measurement. By placing the tension checker in the center of the belt and in the center of the span, slowly push down on the rubber knob mounted at the top of the tension checker, stopping when the bottom of the O-ring is in the same plane the belt was previously in. Referencing the plane the belt was previously in can be determined by two methods. In a multiple belt drive, simply deflect until the bottom O-ring is in line with the top of one of the other belts. In a single belt drive, you will need a straight edge or a piece of string to run across the top of the belt, and then deflect until the bottom O-ring is in the same plane as the straight edge or piece of string. Now that we have deflected the belt the recommended amount, the top O-ring will have moved up the plunger and show us the amount of force used. In this case, we have a tension measurement of about 7 pounds. We can compare this to the deflective force charts found in the Browning bearing and belt drive reference guide, as well as online. Our initial measurement of 7 pounds is very close to the recommended deflection force. Please keep in mind that tension is always changing. As the drive runs, as the belt seats, and as the belts wear into the groove of the shiv, you are going to see tension change. In an optimum situation, we would recommend to retension after 20 minutes, 24 hours, and again after 48 hours.